find the length of PQ, and PQ happens to be the hypotenuse of the right angled triangle. So we need to apply the principles of Pythagoras theorem. Therefore, with Pythagoras, it states that the square of the hypotenuse should be equal to the sum of the squares of the two other sides. So we should have PQ squared should be equal to PR squared plus RQ squared, where PR is 12 centimeters squared plus RQ is also 5 centimeters squared. So 12 centimeters squared gives us 144 centimeters squared plus 5 squared is 25 centimeters squared. So we now have our PQ squared to be equal to 169 centimeters squared. But if we want to do away with the square, we are looking for PQ, not PQ squared. So we find the square root of both sides, PQ squared, the square root of 169 centimeters squared, such that square cancels the root. So PQ will now be equal to root of 169 is 13 centimeters. So the length of PQ is 13 centimeters. Also, per the question we have here, we are now finding PT. So we will use the same approach to find PT, where Pythagoras states that the hypotenuse, which is 17 meters squared, should be equal to the other two sides. So we have 15 meters squared plus PT squared, such that we now have 17 meters squared minus 15 meters squared to be equal to the length, that is PT squared. I just moved the other one to the other side, that is why it became negative 15. 17 squared is 289. So we have 289 meters squared minus 225 meters squared is equal to PT squared. So 289 meters squared minus 225 meters squared should result in 64 meters squared being equal to the length of PT squared. So if we want to do away with the squares, we need to root both sides. So we have root of 64 meters squared is equal to root of PT squared, such that this cancels that. Therefore, root of 64 is 8 meters, equal to the length PT. So per the drawing we have over there, if you have any right angle triangle where the hypotenuse is 17 meters and the height is 15 meters, then it is obvious the base needs to be 8 meters.